The masses of apples from a certain farm has mean mu and standard deviation 5.2. The farmer says that the value of the mean is 64.6. A quality control inspector claims that the value of mu is actually less than 64.6. In order to test his claim, he chooses a random sample of 100 apples from the farm. So the sample size is 100. And the mean mass of the 100 apples is found to be 63.5 grams. X bar is 63.5. Carry out the test at the 2.5% significance level. 2.5%, so alpha is 0.025. We are carrying out a hypothesis test. The farmer claims that the mean is 64.6. What we are testing is the alternative, what the quality control inspector claims. He claims that the mean is less than 64.6. So the alternative hypothesis, mu is less than 64.6. Since n is large, and the standard deviation of the population is known, then the test statistics that we use is a Z statistics. So the test statistics that we are going to use is Z here. This is given by X bar minus mean divided by sigma over square root n. And this Z here follows a normal distribution, the standard normal distribution. The value of the test statistics in this case, Z here, we have X bar equals 63.5, and assuming that the null hypothesis is true, mu is 64.6. Standard deviation is given as 5.2, and square root of n is the square root of 100. So the value of the test statistics is negative 2.115. We need to find the rejection region now and see whether the value of the test statistics falls into the rejection region or not. So we reject the null hypothesis since this is a one-tailed test where mu is less than 64.6. So this is 0 from a standard normal table. And this value here, this region here, has an area of 0.025. It is less than. So we need to find this exact value. From the standard normal table, we found that this Z value is negative 1.96. So the decision rule in this case is to reject the null hypothesis when the value of the test statistics falls into the rejection region. We reject the null hypothesis when mu is less than 64.6. So yeah. So over here, we reject the null hypothesis when the value of the test statistics is less than negative 1.96, which is the critical value here. And since the value of the test statistics, so now our decision, the value of the test statistics is negative 2.115, negative 1.96, so negative 2.115 must be somewhere here. Since the value of the test statistics is in the rejection region, then we reject the null hypothesis. And the conclusion, since the null hypothesis is rejected, we conclude that the alternative hypothesis is true. We say that there is enough evidence to conclude that the inspector's claim is true. Part B, later another test of the same hypothesis at the 2.5% significance level with another random sample of 100 apples is carried out. Given that the value of mu is in fact 62.7, calculate the probability of a type 2 error. So let's see. Type 2 error is the error committed when we retain the null hypothesis given that the null hypothesis is false. That is what we have for a type 2 error. So if the null hypothesis is false, to retain the null hypothesis, first of all, we need to find the value of x bar when we retain the null hypothesis. So we know that previously the mean is 64.6. Previously, we are testing that mu is 64.6 against the alternative that mu is less than 64.6. So if the value of x bar is less than a certain value, then we would retain, if the value of x bar is greater than a certain value, then we would retain the null hypothesis. Because if the value of x bar is less than a certain value, we reject the null hypothesis. We want to find the cutoff point where the hypothesis is rejected or when the hypothesis is retained. It matters not. Now, based on what we did just now from what we had just now, we know that this is z, this is 0 here, and then this is negative 1.96. So this area here is 0.025, which is a 2.5% significance level. So when the standardized test value, when the z statistics is less than 1.96, we will reject the null hypothesis. When it is greater than negative 1.96, we retain the null hypothesis. Now, the distribution that we used just now, the general normal distribution that we used just now, based on the null hypothesis, this is 64.6. Now, corresponding to this 1.96, negative 1.96 here, this area, this region has an area of 0.025. We need to find this value. This is the cutoff value where the hypothesis is rejected or retained. So we must find this cutoff value here. So in order to find this cutoff value, these two values are relevant. So they're actually the same. So over here, let's say this value is m here. And this x bar here follows a normal distribution with a mean of 64.6 and a standard deviation of 5.2 over square root of 100. So over here, this standard deviation is 5.2 over square root of 100, which is 0.52. That is the normal distribution that we have. We need to find this value m. Now this m is standardized to become negative 1.96. To standardize m minus the mean, which is 64.6, divided by the standard deviation, 0.52, this should be negative 1.96. We are working backwards to find this cutoff point. So m here is 64.6 minus 1.96 times 0.52. Upon rearrangement, we have 63.5808. To find the probability of a type 2 error, that is the probability of retaining the null hypothesis. So to find the probability of type 2 error, This is the probability of retaining the null hypothesis when the null hypothesis is false. So to retain the null hypothesis, we need to find the probability that the sample mean must be greater than this value, 63.5808. If the sample mean is less than this m value, then of course we reject the null hypothesis. When the null hypothesis is false, now the condition is the null hypothesis is false. When the null hypothesis is false, this is the null hypothesis that we have. And you're given, in fact, that mu is 62.7. Then the sample mean x bar follows a normal distribution. But in this case, the mean that we use is 62.7. If null hypothesis is false, then the mean of the sampling distribution cannot be 64.6. That is when the null hypothesis is true. So mu must be 62.7, and we use the same standard deviation. The standard deviation is 0.52 here. We find the probability using this sampling distribution now. So to standardize, we have z greater than 63.5808 minus the mean, which is 62.7, divided by the standard deviation of 0.52, which gives us a value of 1.694. From the standard normal table, let's see, this is 1.694. This is the value that we want. This is the value from the standard normal table, which is 0.9549. The value that we want is 1 minus that. And that is 0.0451. So the probability of the type 2 error is 0.0451.